this problem right here, problem 5, and we have a matrix, a 3 by 3 matrix with all these nice entries, and we're given 3 vectors, and we're asked to see if any one of these vectors are eigenvectors, meaning vectors that when subject to this transformation matrix A, remain scalar multiples of what they originally were. In other words, this right here, if I apply the transformation A to the vector k, and I get a scalar times that vector, then k is an eigenvector of A, because it's one of those special vectors that does not get knocked off of its span during the transformation A. And the way to do it is to, I would do it in MATLAB. So let's go to MATLAB and let's see how we could do this. I would just do this. I would multiply A and the vector k, and the result of that, I would see if there's any lambda that I can factor out that'll get me back to k. And I'll do it for each one of the cases. So let's go to MATLAB right here, and this is exercise 5. Okay, so let's define the matrix. Well, clearing all old variables first. Variables, and it's going to be sims. Oh, no, it's going to be clear all. Then we're going to define a matrix. And to define that, we're going to assign it some name. I named it A, and then we're going to put 1, -2, and 2, semicolon after the first row, 2, 1, -2. This is going to be the second row. Third row is going to be 2, 2, and 1. Then we're going to put a semicolon because I don't want the output to show. And then I'm going to define K1, K2, and K3, one at a time. So I'll put here defining the vectors. All right, we got K1 is equal to 0, 1, 1. All right. Then here we have another vector. 4, -4, 0, 4, -4, 0. And we close that as well. And then we have this last vector, and that's -1, 1, and 1. And we don't want that to output either. Now we're going to checking each multiplication. And we're going to get K1, K2, and K3, and we're going to multiply them by A. You have to multiply them on the left, otherwise it wouldn't be defined. And then we're going to look at the results. Okay, so let's see. Is there a way to get from this first vector back to this? No, I don't see it right off the bat. However, this one, it seems like it's just this vector multiplied by 3. Because if I do 4 times 3, I get 12. If I do -4 times 3, I get -12. And 0 times 3 is 0. So this one's an eigenvector with a value of 3, which should be one of the eigenvalues of A. And then let's see this one right here. This one is just the original vector, so there's another eigenvalues of 1. So it seems like there's at least 2 eigenvalues, and these 2 eigenvalues are 1 and 3. And these two, K2 and K3, are both eigenvectors. So that's our answer. All right. See you next time.